Hello, everyone, and welcome to today's demo session. This is going to be about creating full VM images and particularly creating full VM images in a new style. So if you've done any work with full VMs and images on ThreeFold Grid in the past or in other environments, virtualization environments, things like this, then this will be something a little bit different than what you're used to. And I think it's got some cool advantages. Here's our agenda for today. So we're talking about full VM FLIS. There is a guide on GitHub. We don't have this in the manual yet, but I'll show you the guide that's there briefly. And I'll talk just a bit about this style of FList and how it works. We'll have the demo where I'll show you how to build one and then how to deploy it. And then at the end, we'll have room for some questions and comments. All right, so as I mentioned, this is a new style process. I'll be showing you around our GitHub repository where we host all of the threefold image scripts and Docker files and things like that. The Docker files are for the micro VMs. For this full VM, it is built using a script. You can also do it manually, so we'll show those steps. And yeah, that's on threefold images, so there's the link there if you want to visit and try this out for yourself. And the key features here, so we have the script that's automated process, so it is fairly simple, as we'll be showing, to take this script and tweak some things if you want, and then build your own image based on those tweaks. The cool thing I think is coolest about this way of working is that the image that you get is just a bunch of files. It'll just be a folder on your computer that you zip up into an archive and then upload into the FList Hub. So this is distinct from the way that we used to do things where you needed to have a raw disk image, and raw images are sort of inconvenient because you have, if you want to look inside them, you have to mount them. They're harder to modify. They contain empty space, or they can. So this is something you have to resize them. In the end, you can end up needing to move around a bunch of empty space if you have any left over in your image. So it's much simpler to just be working with files, simpler to edit, simpler to pass around. And another thing about this is it allows for creating really lean images. So with the old style, we are usually starting with a cloud image base, like an Ubuntu cloud image, and then doing some customizations on top. And these days, the Ubuntu cloud images, I think, are starting at, you're going to be at least a gigabyte just out of the gate. And by using this method, we can start with a base image that's closer to like 300 megabytes at least when it's compressed. And that doesn't have much in it, but it is nice and small, and you can add things if you need them. And actually, what I'll be showing today is how to add some software into the full VM image. And this is based actually on a question I got from Robert. He's not here today. I wish he could be, but he asked me, hey, where's the UFW and Nano inside full VM images now? I said, well, it's not there anymore because they're super lean. But if you wanted to make your own image that had this out of the gate, I'll be showing how to do that today. And of course, you can also install any software that you need into the VM when you deploy it. So that's always another option. You don't need to build a new image, but if you wanted to, this is how you can do it. And custom images are really handy, especially if you need to make like a large number of deployments or doing something more automated. But it can also be nice if you just want a familiar sort of environment whenever you are deploying your stuff. All right, so let's see how to do it. This repository hosts, as I was saying, all of the sort of necessary recipes to create the images that we use for all of the like official apps in the that are used on the dashboard, including our full VM images. One caveat I'll note here is that actually when I was working on some things here, I noticed that there were some improvements to be made. So I'm actually on a branch right now, which is called Fix Ubuntu 24 Full VM. And this has some improvements to the script that are rather important. So if you're going to play with this, I would advise that you check this branch. If the branch is no longer there, then it's probably been merged and you can just go with development branch. Let's see, try to get this merged as quickly as we can, but just for now, take note of that if you want to follow along with what you're seeing here. Check for this branch. And as usual, we could just clone this repository by copying this link and using git. So it would be just like a git clone like this. We've already done that and won't do it again because it takes some time. So I'm just going to pop into TF images here. And I've switched over to that branch. So that would just be a git switch. And before I proceed, I should note that this process is going to work on Linux and probably Linux only. So if you're on Windows, I can recommend a Windows subsystem for Linux setup or Docker desktop. This should work fine inside of Docker, a Docker container, and kind of same story on Mac. Running with Docker would probably be the easiest way to get going on your local machine, or you could deploy a VM on ThreeFold Grid and follow these steps within the VM. Let me flip back here just for a sec. So there's a couple of prerequisites that we're going to need. So I'm just going to cruise in here. This is where we have all of the images. In this case, I'm going to be showing Ubuntu 24.04. As we'll see though, if you wanted to use a different version of Ubuntu or a version of Debian, then you could do that pretty simply by modifying this process. I will also say here that this should work for pretty much any Linux distribution. If you want to make an image based on a different distro, you will need to kind of adapt the steps so that you have the same components in the mix, but this is not only something that works for Ubuntu or Debian, although the steps that we're showing here are somewhat specific. So here I've come into the full VM folder under Ubuntu 24.04, and this is going to show if you want to use the script, you can do it like this. If you want to go through a manual process, this is how you would do it. There's two things that you will need on your local machine or inside of the container or VM that you're going to run this process inside of. So these are your prerequisites on the local machine. One is the Arch install scripts. These are available for Ubuntu and Debian, other Debian-based distros. So you can just do an apt install Arch scripts. We're going to be using the Arch change root script down here, which is really just for convenience. You don't absolutely need this. You can recreate what Arch change root script is doing, but it is rather convenient, so it's a nice thing to have. The other thing that we're going to need is deb bootstrap. So I think if you're on Ubuntu or Debian, that should be there out of the box. In my case, I'm actually on an Arch Linux system, so I installed the Arch install scripts via Pacman, and I also installed deb bootstrap via Pacman. So just want to point that out, like we're using a tool from Arch and a tool from Debian, but these are things that, if you're on Debian or Arch, you can use both of them in those scenarios. If you're on some other Linux, then probably, maybe, hopefully you can also install these. There's always a way. But again, like if you want the simplest thing, even on Linux, you could just fire up an Ubuntu container, and then that should be an easy way to get started. And this script actually installs, it does all this stuff for you. So if you have a fresh VM or a fresh container, then you can just run the script and it will take care of that stuff for you. All right, I think that's everything I needed to say there. So here in the terminal, I'm going to pop into the same. So here's same folder that we were just looking at on GitHub. And I've got some leftovers in here from what I was testing before. So let's just go ahead and remove those to things up. So that this will look like you do that as root. So this, and that's something else I should mention, the script needs to run as root because we're going to be doing a change root operation that requires root. So that might be another reason that you'd want to consider running this inside of a container if you're not totally familiar with what's inside the script, or just want to be a little careful. That might be a good idea. In this case, I've tested this script. I'm confident that I can run it with sudo, so I'll be doing that today. Let's take a look inside the script. So this is what it would look like after freshly cloning the repository. In the beginning here, it's just going to check that we're running as root. It will throw an error if we're not doing that. This script, so as we saw in the README file, flip back here, the way the script is used when we're building our images is passing in an API key from the hub. What I'm going to show today is how to do it without entering that API key. One reason being that that's sensitive information that I don't want to be showing or including a video. And another reason is that it's just a bit simpler to use the GUI, the web GUI inside the hub. So I'll show you how to do it that way instead. And with that in mind, I'm just going to remove some lines here that have to do with the API key because the script is set up to exit with an error or a helpful message if you don't pass the API key. So I'm just going to delete those lines, and overall what I'm showing you is how you can take this script and adapt it to something that can help you for what you need. So I'm also going to remove these lines, which are going to be attempting to install the Arch install scripts because I already have those on my local machine, and the local machine is not Debian based, so that'll just throw an error when it tries to run apt-get. And then I'm just going to flip quickly down here to the bottom and also delete some lines here that have to do with uploading the final product to the hub. So with that, now we have a nice compact script that just does the essential things here. And I'll just walk through it quickly and show you what it does. So first, it's going to create a directory that we're going to be installing our image into. We're going to use deb bootstrap to bootstrap and Ubuntu Noble, so that's Ubuntu 24.04. So deb bootstrap is a tool that you can use to install a Debian or Ubuntu system into, like, if you had a laptop or something that you wanted to run Debian on, you could do it with deb bootstrap rather than using like the standard installers. So this is just a way to download some packages and put them into a folder on your computer essentially. And so it's actually Noble here is the one that's going to be specifying which version we're using, and then we have the path to the archive here. So if you were wanting to install a different version, like we could type like JME here or whatever for an earlier version of Ubuntu, and then if we wanted to change this, there's surely some path for like Debian if you want to install Debian. So I won't cover that in detail here, but you can find the appropriate deb bootstrap command for the version of Ubuntu Debian that you want to use. All right, now down below here is actually a script within a script. So this script is going to run inside of the change root environment. So this is essentially a script that's running inside of our image or inside of our VM. It's not a VM yet, but this is how we will be installing any custom software that we want and just prepping the image. And we can see that this is rather simple. We're just putting a DNS server in here so that we can contact some things over the network to install the packages. And then we're just doing some standard like apt-get update, apt-get install. This is where we're installing basic things that we need. So Cloud Init is a big one. Open SSH servers so that we can SSH to our VM after it's deployed. Curl is in here. for some reason that we need. There's something that needs to download something using curl later. Init ramfs tools and Linux virtual. These are kernel stuff and init ramfs stuff. So this is basically just giving us the kernel that and the set of packages, kernel modules that is appropriate for a virtual environment. And then we're going to regenerate the init ramfs. So these are important bits here if you want to try to recreate this with like another operating system. You will need cloud init because that is how ZOS is passing in the information to the VM in terms of users and SSH keys and things like that, and how to set up the network. This is important too. So this virtiofs, this again, when we're talking about this style of VM image just being like a bunch of files, the way that ZOS is going to provide this image into the hypervisor is over virtiofs. So this needs to be present in the init ramfs so that the VM can boot up and it can actually mount its root file system. So these steps are important, but if you just want to come in here and play around and build an image, you don't need to worry about that stuff. It's already there and it's working. Now, if you want to install some extra software, we can do it right here on the apt-get install line. So that's what I'll show now. I'm just going to write UFW and nano, so a couple of packages that you would find inside of a normal Ubuntu environment, and which our user was asking about. And that's really all that we need to do. In the case of UFW, this is actually a service that is going to be hopefully started up when our VM starts. A nice thing about this environment is that there's nothing more that we need to do. When we install UFW, apt-get is going to take care of the rest in terms of making sure that it's actually there. So we'll see that when we deploy the VM. So this is nice. We can just, if we want to add packages, mostly that's all we need to do, and there's nothing more. If you wanted to do something like provide some default firewall rules that are different from what's in there, you could also do that here inside this script. You could write a file, or you could you could do that inside the script, or you could also do it by modifying the resulting folder that we'll see on that comes out on the other side. All right, so everything here between the EOFs, that's the script that runs inside. And after that, these steps are basically just making sure the script is executable. This is where we're going to do the change root. So after we've bootstrapped the thing, we're going to do a change root inside, which basically just, it makes the folder look like our new root file system, and this is necessary to do things like apt-get. So we need a change root. Change root is also essentially like how Docker is working. So if you've ever used Docker and you do this thing where you create a new container and then you're inside and you have a full root file system that's different from your local machine, that's the same idea here with the change root. So we're just going to step inside of the new file system that we're setting up. We're going to run that script. So that's here. We're running a script that we wrote lines above. Then there's just a bit of cleanup, basically to remove the script file and to remove some system files that are representing hardware devices that will no longer be relevant. And then at the end, we're going to create a compressed archive with the contents of the folder that we've made. All right, so that's the full script, and you can modify the script to do other things, such as if you wanted to, say, copy some additional files into that VM image, you could do that somewhere down here maybe, and copy some files from your local machine into the image. And you can also do that manually after the build process is complete. So I'm going to go ahead and just save this file, and then I'm going to run it. So we could make the script executable and execute it directly, but here I'll just use bash to run the script. Okay, that's finished. Let's clear it up and let's see what we have here. So this folder is where all the files are, and then we've automatically created a compressed archive. So at this point, you could actually look inside of our Ubuntu Noble folder, and this just looks basically like typical Linux root file system. We got Etsy, and we got var, the user, and everything else. So again, if you wanted to, you could modify files inside there. There's some things, like I mentioned, like installing packages. If you want to do that, you need to be inside the change root. But if you just wanted to like change some config files, things like this, you could do that now, just like a normal file on your computer, which again is nice because if you're working with a disk image, then you don't have this ability to just reach in a simple way and change
Mhm.
things.
So
If
let's
you
say at this point you forgot to add some stuff. You go back with Arch root and then you can add more packages, right?
You could, yeah. So you could do the arch ch root. So that would just look like this. And after you did that, you could run apt-get and things like that. Um,
Nice.
we need to be root. And so it's not a mount point, but we don't need to worry about that. So I could, yeah, I could run apt install whatever here. And then when you're done here, you can hit Control D or exit to come back to your regular shell. So
That's cool.
yeah, if you wanted to do that, or you could use, again, if you just need to edit some files or add some files, you can do that in the usual way. And then you would want to run the tar command again. So that's, should have the X, there's a great XKCD comic about how someone's saying, oh, if you can just remember the proper invocation of tar, then you'll avert the end of the world. And the guy's like, sorry, everybody, like we're doomed because you can never remember how to invoke tar. All right. But we can nerd jokes. All right, but we can always come into our handy dandy script here, and this is the command that you would want to run again in order to create a new archive based on your changes. But we don't need to do that because I didn't make any changes. What I am going to do here is just move this to just basically rename the archive to reflect the changes that we made. This is important because this file name is going to become the name of our F-list. So if you're doing some changes and you're making some different images, you might want to rename them before you upload them. Otherwise, the hub is just going to overwrite whatever you had before. Okay, so now we're done here, and I can come to the hub, and the process here to upload your file is first need to log in. So grab ThreeFold Connect app, cow. Okay. I will show quickly, if you wanted to do everything from the command line, you can generate your API token here. You could put that in for the script, it would take care of it automatically. But here, what we do, upload file, choose the file, and then we can just choose our file there. I'm not going to show this entire process because again, my connection is rather slow, but I have already uploaded the result of previous build. So here's my F list. And like I was saying before, this name is based on the name of the file that we uploaded. So what I can do now is just copy the address here. We can also come in here and hit this copy button. We just want the URL of our F list. And then we'll come to the dashboard and we'll deploy this for a test. So that's the one that I deployed before. I think I already deleted it. So maybe I should start kind of from the top here. So in the dashboard, we want to open deploy, virtual machines, full VM. And then for the image, I'll open this, I'll hit other, And I'll paste my FList link in here. For networking, I'm going to grab a public IPv6 address just for a quick.
And you don't need
demo.
any entry point?
No, yeah. So this technically probably shouldn't appear here for full VM because the entry point is handled via the initramfs. So I think this actually shouldn't be here, but there might be a reason for it. I'm not totally sure about that, but yeah, we don't need to specify this for the type of full VM that we're using now. Entry point is more, it's more of a thing for micro VMs. Micro VM, you definitely need an entry point. For here, I don't even think it has an effect. I think it's just an artifact here in the GUI. Yeah, great question. I will select a node. I use manual selection here. Node 3, I think this is one I used before. And if the node already has the FList downloaded, that can help things to move a bit faster for the deployment. But these, again, these images they're not huge, so this part tends to happen pretty quick. We can check, just check the size here. So, yeah, 241 megabytes for the compressed image, which is pretty nice. All right, so now we're deploying. And after deployment is complete, I'll just connect with SSH and show off the fact that the things we added to our image are actually there. So as usual, SSH to root. This might take a bit. With full VMs, they take a little while to start up. So that's one thing to not be panicked about here. I surely wasn't panicking about this when I was testing this
Of
image
course,
just
of
before
course.
before the demo. All right, so you have to give it a minute. It's another thing about full VMs, they take a bit longer to boot up. Micro VMs tend to be very fast. And once we're connected, then we could do something here like system control status UFW, and we can see that
Nice.
uncomplicated firewall is, it's not only installed, but it's actually already running out of the box. And if we want to nano our config here, then now we can edit our config. Yeah, so now we have an image with UFW and nano, some familiar tools. You can stick whatever you want to into your own image by just appending some packages onto the list there. I will mention that there are some other things you can do that are potentially more interesting than just installing software. One exploration that I did is with having encrypted files, like root file systems from boot in VM images. And that's a place where being able to modify these images and do things like regenerate the initramfs and mess with the kernel and kernel modules and stuff like that. That's where it becomes like much more important, because those are things that you, I guess, technically can do after a VM has booted up. But if you wanted to have like a VM that's always encrypted from the start, then you need to do that in the image. So just to kind of also whet your appetite about the sorts of things that can become possible when you get into the working with the images like this, and also with full VMs. So you have full access to the kernel. You can install kernel modules. You can install custom kernels if you want, things like that. So that's really the big benefit of a full VM over a micro VM. Alrighty, so that was the demo. That's all I got. Hope you guys enjoyed that one. We'll catch you next time. All right, bye for now.